Here, solve the differential equation below using the integrating factor and the Laplace transform methods. All right, we'll start out using the integrating factor method. Now, what I plan to do after the integrating factor method, I will just break from it, and then in a separate video, I'll use the Laplace transforms method. All right. Now, what I want you to do is pause the video and work it out using the integrating factor method. Okay, are you finished? Let's see something here. So here, what you need is to write it in the form dy by dx plus py equal q. If it was not already in that form. It's not in that form, so in this case, what we're going to do that, divide by 7. When we divide both sides by 7, we're going to have 7 will cancel 7, so we have dy by dt plus 49 over 7, which is 7, y equal 28 over 7 is 4. Okay, good. Now, the next thing is to identify P and Q from the general form dy by dx plus py equals q. You can see that P is 7 and Q is 4. All right? Now, the next thing is to find the integrating factor. All right, the integrating factor. You write the integrating factor as e to the integral of p dt. Now, what is that? Well, it is e, the integrating factor is equal to e to the integral of 7 dt. Now, in this case, the integrating factor is e to the, when you integrate 7 with respect to t, you get 7t. All right? Now, the next step, multiply by the integrating factor. You multiply both sides by e to the 7t. So, e to the 7t dy by dt. So, we have e to the 7t dy by dt. All right? Plus 7y times e to the 7t plus 7y e to the 7t equals 4 e to the 7t equals 4 e to the 7t. So that's the integrating factor there. So e to the 7t, e to the 7t, the integrating factor here, e to the 7t again, e to the 7t, integrating factor here, e to the 7t again, e to the 7t. Now, after that, you're going to identify the result of the product rule. That means you have integrated a product of two functions using the product rule. What was the result? Now, here, if you look carefully, You see that you differentiated y here, and you have e to the 7x. Right? Plus, in the next case of the product rule, you're going to hold y and differentiate e to the 7x. So guess what? You hold y here, when you differentiate e to the 7x, you get 7e to the 7x. So that's what you had there. See that? So you're looking at the derivative, d by dx of a product. Well, I said x, it's t, right? It's 7t, right? So it's e to the 7t. So here, you hold e to the 7t, differentiate y, plus you hold y, differentiate e to the 7t. So what you get is the derivative of the product y, e to the 7t. Alright? Now that is equal to what now? 4e to the 7t. Good. What's the next step? Now remember, you need to release the y from inside there. So what you're going to do is integrate. You're going to integrate. Now you have the integral of d by dx of e to the 7t, of y e to the 7t, I mean, equals the integral of 4e to the 7t. Now here, when you find the integral of the derivative of a function, you get back that function undisturbed. It's like the integral and the derivative cancel each other out, alright, leaving the function undisturbed. So you have y e to the 7t is equal to, now this is going to be 4 times 7e to the 7t. If you remember using your chain rule, right? If you're not entirely sure what happened here, you could use a chain rule, make say y equal e to the 7t, u is equal to 7t, so y equal e to the u, and then you find you go and work it out, and you will see it would make it plain to you. But if you are accustomed to using, which you should be accustomed to using the chain rule by now, so you can quickly identify that when you integrate e to this, hold on, you are integrating, oh, it's not the chain rule, it's not, you're not differentiating, you're integrating, right? You're integrating, right? My mistake. I was thinking of the fact that you're differentiating, you're integrating here, so it's going to be e to the 7t over 7 plus c, right? That's integration. All right. So now, yeah, it would be integration by substitution, or you get this, right? If, let's temporarily work this out. If you say y is equal to e to the 7t, and you integrate, so you're finding the integral of y, which is the integral of e to the 7t with respect to t. You say let u be equal to e to the 7t, and then what you would have is the integral of e to the u dt, but you want e to the u du, so differentiate this and say du by dt would be 7e to the 7t. Then what is dt? When you transpose to make dt the subject, dt would be equal to du over 7. Dt would be equal to du over 7e to the 7t. Alright, so, okay, it would be du over 7e to the 7t. Right? U equal e to the 7t. So what you would have, is du by dt is 7e to the 7t, right? And then dt would be du divided by e to the 7t. Luckily I worked this out. It was e to the 7, it would be divided by e to the 7t. 7e to the 7t. Alright? So here, oh, no. You're integrating e to the 7t, right? So it's e to the 7t. So u equal e to the 7t. And then du by dt with the 7e to the 7t, right? So dt would be du over 7e to the 7t. So what you have is the integral of e to the u times dt, but dt is du over 7e to the 7t, which is the integral of e to the 7. Oh, I did it wrong, you know. I have to start again. My. U is not the whole of e to the 7t. You're integrating, let me do it in a different color. You're integrating e to the 7t dt. So u is equal to 7t. That's what I should have done. My. So if we do that, we would have du by dt is equal to 7, right? And dt would be du over 7. So this would be the integral of e to the u, right? dt. But we don't want any e to the u dt. We want e to the u du. But what is dt? dt is du over 7. So this would be du over 7, right? So that would have been it, right? Before I made the mistake of saying u is the whole of e to the 7t. It's just 7t. I got mixed up there. So what we have, that's how you get the 7 under here. Alright? Just a reminder of integration by substitution to get that. Alright, so here what we have then is that y e to the 7t is equal to 4 e to the 7t over 7 plus c. And then after that, if we divide by e to the 7t, we have y equal, this would be, well, e to the 7t would cancel itself. So it would be 4 over 7 plus c over e to the 7t. Alright, so let's review. Alright, let's review it. So here we have 7 dy by dt plus 49y equal 28. Good. We need to write it in the form dy by dx. I'll put dx there, but it should be dt. dy by dt plus py equal q. So we divide by 7, we get dy by dt plus 7y equal 4. Then what happens after that? We identify p and q. So we get p is 7 and q is 4. So we write the integrating factor e to the integral of p dt, which in this case is e to the integral of 7 dt. Alright? The integrating factor is e to the 7t, because when we integrate 7 with respect to t, you get 7t. Now we multiply both sides by the integrating factor, so you get e to the 7t times dy by dt plus 7 times y e to the 7t, 7y e to the 7t plus 4 e to the 7t. You identify what resulted in the derivative of a product rule, so you identify the product. Here, you hold e to the 7t, differentiate y plus, you hold y, differentiate e to the 7t. So we have y e to the 7t as a product. So it's the derivative of the product y e to the 7t equals 4e to the 7t. Next, you integrate both sides. So when you integrate both sides, you integrate d by dx of y e to the 7t equals integral of 4e to the 7t. Then this results in y e to the 7t, because your integral of the derivative is as if the integral and the derivative cancel each other out, leaving the function undisturbed. So you have y e to the 7t equals 4 times e to the 7t over 7 plus c, right? That's where I had showed the reminder, the review of integrating by substitution to see how this 7 got under this, and then I make the u be the whole e to the 7t, but that shouldn't be. I realized later on that it's really, the u is equal to 7t. So when you integrate by substitution, make u is equal to 7t and then you work it out. Then y e to the 7t equals 4e to the 7t over 7 plus c. So this is what we get. Alright, so what we're going to do, oh, by the way, let's put in an initial condition. Initial condition, that would be good. Y of 0 is equal to 1. So y of 0 is 1. When x is 0, y is 1. What happened here? If we put in that initial condition, when x equals 0, y equals 1, we could find c. So 1 is equal to 4 over 7 plus c over e to the 7 times 0, which is 0, e to the 0. But e to the 0 is 1. We can't scroll down anymore, we run out of scrolling space. So what we would have is 1 minus 4 over 7 is equal to c over 1, which is c. So it's 1 minus 4 over 7. Let's work that out as a fraction. 1 minus 4 over 7. 1 over 1 minus 4 over 7 is the same as 7 over 7 minus 4, 7. 7 minus 4 is 3. So it's 3/7. So c is equal to 3 over 7. Alright? 3 over 7. So the result we would get is that y is equal to 4 over 7 plus 3 over 7 e to the 7t. Alright? Let me write it up here. Y is 4 over 7 plus 3 over 7 e to the 7t. So y equal 4 over 7 plus 3 over 7e to the 7t. Y equal 4 over 7 plus 3 over 7e to the 7t. And the general solution was 4 over 7 plus c over e to the 7t. So the general solution was y equal 4 over 7 plus c over e to the 7t. Alright, so these, what we have here are the solutions. Alright, this part was the initial condition. Alright, so in our next video, we will redo this question but using the Laplace transform. So, and I put a link to the playlist in the description of this video so you can click on it and follow it. I'll see you in the next video.